Hi everybody. Just a warning, this video is going to compress a whole lot of information into a short amount of time so that you can get some problems done quickly. So if you notice, I already have some information written on the right side of the screen. The first is one way you can interpret what is called the geometric mean of two numbers. So in this proportion equation, we have A is to B as B is to C. Notice the number B is repeated in the proportion. That's important. When you have three numbers like this, A, B, and C, that satisfy this sort of proportion equation, we say that B is the geometric mean of A and C. Now, we could talk about the geometric mean for a good half hour, but I don't think you want to watch a video that's that long. So, if you look at the problem we're going to do, so look at the triangle over here to the left, we have a right triangle and we have an altitude drawn. An altitude connects a vertex to the opposite side, making a right angle. Long story short, the three triangles you see in this picture, the large triangle that you start with, the small one that's on the upper side of this diagram, and I guess the medium side one that's at the bottom, all three of those triangles are similar. And you can attack these triangles by drawing them separately and applying what you know about similarity. However, that's a little bit time consuming and it's sort of difficult. So look at this first sentence written in green. It says, the altitude is the geometric mean of the parts. Now, the word parts is somewhat vague. That's definitely not a technical math term. So in parentheses I wrote of the hypotenuse. So in this diagram, x is the altitude, and the hypotenuse has been divided into two parts, 64 and 36. So this sentence says that the altitude, which is labeled with x, is the geometric mean of 64 and 36. So if you know that sentence, what that means is you can immediately write down a proportion equation, because the proportion equation that's at the top right is how geometric means relate three quantities. So let's put this together. My suggestion is that you start with a proportion equation, fraction bar equals fraction bar. Now the geometric mean occurs in two places, once in the top and once in the bottom. And this sentence says, the altitude is the geometric mean. Well, the altitude is labeled with x. So we put that in two places, once in the top, once in the bottom. It doesn't matter left or right. I'll just write it like this. So the altitude, x, is the geometric mean of the parts. Well, the two parts are labeled, 64 and 36. And there you go. Solve this equation for x. Now I'm going to do about 4 examples in this video, and I don't want it to get too long. So solve this equation in your calculator if we're solving equations like that in class. And if you're not using the calculator, then you'll know how to solve this equation anyway. So either way, I'm going to stop here. Once you write the equation down, getting x is a really quick process. So once again, all we're really doing is interpreting this first sentence. The altitude is the geometric mean. So the altitude is in two places. It's the geometric mean of the two parts. So the two parts are in the other two places of the proportion equation. And now you're done. You just solve it. So let's do another example. So this is a wholly different diagram. Notice the altitude that's in the dotted red isn't even labeled. But let's read the second sentence. The second sentence says, a leg is the geometric mean of the hypotenuse and the part. And in parentheses, again, the word part is not a technical math word. So the part that we're talking about is the part adjacent to the leg. Now, this sentence is a little bit more complicated, so I think it's worthwhile to color code this. a leg? Well, that's talking about our original triangle, which is a right triangle. A right triangle has a hypotenuse, the longest side, and two legs. So x here is a leg. So this leg, which is marked with this pink color, is the geometric mean of the hypotenuse. Well, I'm not going to label that. The hypotenuse is the longest side. That's labeled with 100. Okay. Well, it's the geometric mean of the hypotenuse and the part. Well, which part? The hypotenuse is divided into two parts, as we saw with the previous problem. Well, what we're talking about is the part close to the leg, adjacent to the leg. So that's in this, this golden color. So once you see how the various pieces of this diagram are labeled, you can write down a proportion equation. Fraction bar equals fraction bar. So now let's read the sentence again. A leg is the geometric mean. And remember, the geometric mean, that shows up in two places in the equation. So in this diagram, the leg is labeled with an x. So x shows up in two places. So x is the geometric mean of the hypotenuse. Well, the hypotenuse is labeled with a 100. And the part that's adjacent to the leg, well, that's 36. Again, I'm not going to solve this equation. Solve it in a calculator if that's what we've been doing in class. Solve it by hand if that's what we've been doing. The key to dealing with this sort of right triangle where you have an altitude drawn is to read and know and interpret these two sentences. So let's do a couple of more examples that get slightly more complicated. Although if you know the two sentences, none of these are terribly difficult. Okay, so let's see what we have here. I think that this diagram is going to correspond to the second sentence, because the second sentence talks about a leg. Well, here we have 60. That's a leg of the right triangle. So that's going to be the geometric mean of the hypotenuse. We'll get to that in a second. And the part that's adjacent to the leg. So we'll use the same color. Let's see, the part that's adjacent to the leg. So our leg is labeled with this pink color. Our part is close to the leg. So this gold, 36. Well, now let's talk about the hypotenuse for a second. The hypotenuse of our original right triangle, well, that doesn't have a label on it. So you'll have to add the two parts together. So the hypotenuse is x plus 36. And now we're ready to write a proportion equation. So fraction bar equals fraction bar. And let's read the sentence. A leg is the geometric mean. Well, our leg was labeled with this red color. So 60 is going to be in two places in our proportion equation. That leg is the geometric mean of the hypotenuse. So the hypotenuse goes in one place. That's x plus 36. And the part that's adjacent to the leg, well, that's the gold color. That's 36. Again, solve the equation in the calculator if that's what we've been doing, or by hand if that's what we've been doing. If you are going to do this by hand, please note 60 over 36 reduces quite a bit before you get started, as 12 is a common factor with those two numbers. Alright, so I think we're going to do one more example, going back to the first sentence, and let's see what that is. So yeah, here 48 is labeled with, or 48 is the altitude, and that has been labeled. So let me see if I have any different colors here. The altitude. The altitude. I'll do that in this lime green. The altitude is labeled with a 48. The altitude is the geometric mean of the two parts of the hypotenuse? Well, for the hypotenuse, its two parts. One of them is labeled with this 36, and the other one does not have a label. So be careful. Since we need to talk about this part on the left, you'll have to use the entire hypotenuse, which is labeled with x, to see that this part on the left is x minus 36. So now let's just read and interpret the sentence. Again, my hint, fraction bar equals fraction bar. The altitude is the geometric mean. The altitude is labeled with 48. That means 48 goes in two places in our proportion equation. So the altitude is the geometric mean of the two parts. One of them is labeled with a 36. The other is labeled with x minus 36. Once again, solve the equation using whatever method we've been using in class. And that's how you deal with this very specific type of right triangle. When you have a right triangle with an altitude, again, making three total right triangles that are all mutually similar. Now, what you could do is draw all three of them separately, label all of their sides, and use the types of similarity arguments that we've made in prior videos. However, if you can just remember these two sentences written in green on the right-hand side of the screen, it makes these problems so much faster. So, that's how you deal with these. Hope it helped. See you next time.